In the first section of this module, called Nullability, we are going to discuss nullable types in Kotlin. The problem of nullability is sometimes referred as billion-dollar mistake. That's how Sir Tony Hoare, the inventor of null reference, later called his invention. The problem is that these null pointer exceptions problems are really hard to fix, and even if you go for details, you often can see just, sorry, null pointer exception was thrown. And the current approach, the modern approach, which is not unique to Kotlin, is to convert these problems, these exceptions, from runtime exceptions to compile time errors, to make it compile time problems, so that we could prevent these exceptions when we write the code and compile it, rather than later in production. Kotlin distinguishes nullable types and not nullable types. If you use the regular type as string here, you can only store non-nullable objects there. So you can't store null references. There, if you try, the Kotlin compiler will complain. If you want to store null somewhere, you need to declare a variable as of nullable type. You add question mark to string, like in this example, and in this case, you can store either null or non-nullable value here. If you try to dereference a value of non-nullable type, everything is fine. The Kotlin compiler doesn't complain because it's sure that the variable is not null. However, if you try to dereference the value of nullable type, the Kotlin compiler says that's not possible because this expression of nullable type might be null under the hood, and it can throw null pointer exception. So what can you do if you want to dereference an object of nullable type? The easiest way would be to check that explicitly that your reference is not null, and after that you can simply dereference it. However, even IDE will suggest you the better way to express the same logic. You can replace if expression with so-called safe access expression, and it looks like the question mark and dot. And what it does, it checks whether the receiver is not null. If it's not null, then it calls its member and returns the result. Otherwise, it returns null as a result. So the other way to express that, you can, when you assign a result of safe access call to somewhere, or you return to assign to a variable, that is the same as using this explicit if form. The question for you would be, what is the type of length variable in this example? What do you think? So the answer is nullable int. S.length return you a variable of int type, and when you use safe access, that makes the result nullable as well. So for instance, if you want to later dereference it, you will also need to use safe access. If you want to, here the result type is nullable. If you want to make it non-null, you will need to provide some default value. So in if expression, we use else 0. When using safe access, you can use so-called Elvis operator and provide the default value that would be used if the right expression is null. So this Elvis operator, there is this scheme. So it's either right expression if it's not null, or left expression if it's not null, or right expression if left expression is null. Why it's called like this? You can guess it if you read the operator as an emoticon, and this name comes from Groovy, and actually the whole bunch of operators comes from Groovy, and there they proven to be very useful for working with expression that can be null. So this Elvis operator is not the Kotlin invention. The question for you here is what is printed here in this case? So in the first line, we sum up 0 and 2, having 2 as a result. In the second line, because b is not null, we sum up 1 and 2, having 3 as a result. So the answer is 23. Let's go back to how we can cope with expression of nullable types. And the Kotlin compiler supports contraflow analysis. So if you check explicitly that the reference is null and you fail or return, afterwards you can access it without self-access. So the same feature smartcast is used. So here the compiler knows that its variable is smartcast to non-null type. So you can either use fail or return in such constructions. If you want, you can throw null pointer expression. So in this case, for this, you will use this two exclamation mark operator, and it throws null pointer exception if its operand is null. Afterwards, you can dereference it safely. So again, if it's it throws null pointer exception if it's null, if it's the operand, or just returns the operand if it's not null. A couple of more words about this two exclamation mark operator. By default, try to avoid it. So we have it in a language, and there are some very few use cases when the Kotlin compiler isn't smart enough. So you are sure that that in this case the expression is not null, but Kotlin compiler cannot infer that for you. So in this case, it makes sense to use this two exclamation marks operator, but overall, try to use safe operators, self-access, else operators, explicit checks to cope with nullability. Use it with care only when it's necessary. And it's still better than in Java, because in this case, when you use this two exclamation marks operator, that means that you explicitly emphasize where null pointer exception can be thrown. And if it's thrown, you can see directly what might be the course. And that actually means that it does make sense to put two operators in one line. So try to use that with care. The question for you to get used to these nullable types is which lines won't compile in this case? Which lines will produce an error? And let's do it one by one. The first function takes the parameter of non-null type, and the function is fine, but the problem is that we can't pass null whenever non-nullable type is expected. So the compiler error says us that null cannot be a value of a non-null type name. So here it is broken, because if it is allowed, then you will have this null pointer exception. That's not the case. This line doesn't compile. The second line, when we make the type nullable, the invocation now is fine. It compiles. However, in the function body, there is an error, because only safe call or non-null call is allowed, and you can't just reference expression of nullable type. Reference of nullable type. And then the next calls fix this problem. So this one is fine. Here we check explicitly and then use smartcast value. It's a possible option. These lines compile. This one also compiles because we use self-access to get the value, and then we compare it with a string. Everything is fine as well. So the answer is the lines 2 and 5 don't compile. Another question for you here, and this one is not trivial, because it might be confusing and sometimes called a puzzler. So the question is, what is printed here? So the answer is quite unexpected. Take this in mind. The possible options are 1, 2, or 3. So the answer is 1 here, and that's because of operator precedence. If you just omit parentheses, by default, some operators take higher precedence than their Elvis operator, and that means that by default the parenthesis would be put around plus, not Elvis operator. If you want to put it around Elvis, then you put that explicitly. So if you are not sure and to make readers to make the code readable for later, just prefer parentheses in all such confusing use cases. Now you know how to distinguish nullable types from non-nullable types, that only expression of nullable types can store null references. You know how to work with them. You can use safe access operator, Elvis operator. You can enjoy smartcast or even prefer throw null pointer exception, but you have to use explicit syntax for that. Next, we're going to uncover the details and learn how nullable types are implemented under the hood.